The future of construction is arriving faster than anyone expected. From smarter materials to machines that rethink how we build, these new techniques are cutting time, reducing waste, and opening doors to designs we couldn't pull off a decade ago. Let's take a look at the Verdura soil retention system. It might look a bit dangerous when you first see it, but there's a reason it's built this way. These interlocking blocks create a wall that can hold back a huge amount of soil, even on unstable slopes. As the wall goes up, the open-face design allows plants and roots to grow through it, which actually makes the structure stronger over time. And despite the heavy-duty job it's doing, the installation is pretty straightforward. Stack the blocks, secure them, backfill, and keep climbing. It's a simple system that solves a big problem, keeping roads, hillsides, and properties safe from erosion and collapse. If you've ever wondered how modern bridges go up so quickly, the precast arch bridge in Steinzeug is a perfect example. Instead of building everything on site, massive concrete arch segments are cast in a factory, delivered to the location, and lifted straight into position. Each piece is shaped with millimeter accuracy, so the arches lock together cleanly and form a strong, self-supporting structure almost immediately. Once the segments are set, crews backfill around the arches, add the road layers, and the bridge starts taking shape fast. It's a smart, efficient method that cuts weeks off construction time while delivering a durable bridge built to last for decades. Drivable turf is one of those clever systems that lets you keep a natural grass look while still supporting the weight of vehicles. Underneath the turf, a grid-like structure spreads out the load, stopping the soil from sinking or rutting when cars or equipment drive over it. Installation is simple. Lay the grid, fill it, and grow, or place your turf on top. The result is a surface that looks like regular lawn, but handles far more stress. It's perfect for overflow parking, emergency access lanes, or any area where you want green space without giving up strength and stability. If you've ever wished concrete could be installed as quickly as rolling out a carpet, concrete canvas is exactly that. It's a flexible fabric impregnated with dry concrete mix. Just unroll it, shape it, and add water. Within hours, the material hardens into a durable, fire-resistant concrete shell. Crews use it for ditch lining, slope protection, bund walls, and emergency repairs where traditional pouring would take too long or be impossible. The canvas drapes over uneven ground, cuts with simple tools, and forms a tough, low-maintenance layer that lasts for decades. If you've ever wondered whether a coating can really protect a home from wildfire heat, this California burn test gives a shocking answer. Fire coat is sprayed onto timber or exterior panels, and when exposed to extreme flame temperatures, the surface literally chars in place instead of igniting. The coating expands into a thick insulating layer, slowing heat transfer and stopping the fire from getting a foothold. In the test, untreated wood burned within seconds, while the fire coat panel stayed structurally intact long after the flames hit it. For wildfire-prone regions, it's a game-changing layer of defense. If you think building foundations still requires mountains of polystyrene and messy cutting, Q-Pod's castle system shows there's a smarter way. These interlocking pods snap together to form a clean, modular grid that replaces traditional waffle pod setups. Each unit creates perfectly spaced voids for ribs, beams, and concrete flow, giving you a strong, lightweight, and highly insulated foundation with far less waste on site. The castle layout also improves airflow under the slab and makes service runs easier to plan. If you think foundations always need days of digging, formwork, and concrete trucks, this system will change that idea fast. Peyco's 3D printed pad foundation is created layer by layer using a specialized concrete printer that shapes the entire form without any timber or molds. The printer builds precise cavities for reinforcement, bolt groups, and anchor plates, so everything fits perfectly once the steel column arrives. After printing, the unit is filled with high-strength grout or concrete, producing a compact, extremely accurate foundation that's ready in a fraction of the usual time. If you've ever wanted to lay perfect concrete curbs without hiring a full crew, the Pavimac Mini makes it look almost fun. This compact curbing machine feeds and shapes concrete into a clean, consistent curb in one smooth pass. You simply load the mix, guide the machine, and it extrudes a flawless edge for driveways, garden borders, paths, or small landscaping projects. Its lightweight design means you can maneuver it anywhere, and the interchangeable molds let you switch between different curb profiles in seconds. If you've ever seen old buildings with cracked or crumbling interior walls, Fibre Net offers a clever way to bring them back to life without tearing everything down. Their system uses lightweight fiberglass mesh and special mortars that bond directly to weakened surfaces, creating a reinforced layer that stabilizes the wall while keeping the original structure intact. It's clean, fast, and far less invasive than full demolition, making it ideal for historic renovations or buildings that can't afford long downtime. But what do you think? Should more restorations use systems like this, or do you prefer traditional rebuilds? If you've ever wondered whether a robot-built house can really be stronger than a traditional one, PERI's 3D printed homes make a strong case. Their printer lays down high-performance concrete in thick, layered shapes that naturally resist cracking and can reach 2 to 3 times the compressive strength of standard materials. The process is fast, precise, and uses far less labor and waste than conventional builds. But what do you think? Would you live in a fully 3D printed home? Tell us in the comments. If you've ever wondered how engineers upgrade old city infrastructure without shutting everything down, the Steinzeug Keramo install under Strada del Drosso is a perfect example. These vitrified clay pipes are incredibly tough, resistant to chemicals, abrasion, and pressure, and can last well over 100 years once buried. Crews slide them into place with pinpoint accuracy using trenchless methods, keeping traffic moving above while the new sewer runs silently below. If you've ever tried driving equipment over loose soil and wish someone could compact a clean path instantly, this Steelwrist attachment delivers exactly that. It combines a tilt rotator with a heavy-duty compaction roller, so the operator can shape the ground and roll it flat in one smooth motion. No extra machines, no extra crew. Stabilizing a collapsing riverbank or roadside slope takes precision, and that's exactly where the KEMROC KSI 12,000 comes into play. This machine cuts into the ground while injecting cement slurry, turning loose, unstable soil into a solid, reinforced wall right beneath the surface. The strengthened soil forms a long-lasting barrier that prevents erosion, stops further sliding, and supports the bank without major excavation or heavy concrete pours. If you've ever wondered how builders get clean, solid walls up so quickly, Ytong Panel SWE is a great example of why aerated concrete is still so widely used. These lightweight AAC panels, locked together with tongue and groove edges, go up fast with minimal equipment, and offer strong fire resistance and excellent insulation right out of the box. They cut easily, reduce wet trades on site, and create smooth walls that are ready for finishing almost immediately. It's a smart, efficient system. But what do you think? Would you trust this method on your own build? Let us know in the comments. If you've ever wondered whether fast assembly building systems can actually stand up to real fire conditions, System 3E puts that question to the test. Their interlocking wall blocks snap together without mortar, creating a clean, insulated structure in minutes. But the real surprise is how well they hold up under extreme heat. In the fire test, the blocks maintain their shape, resist flame penetration, and continue to support the wall long after traditional materials would fail. Breaking up old concrete or rocks on site always looks tough. But the Simex CBE 50 makes it feel like a job you'd actually want to try yourself. This crusher bucket attaches to an excavator and chews through demolition waste with a powerful rotating drum, turning chunks of concrete, stone, or asphalt into reusable material in seconds. There's no clogging, no flying debris, and the adjustable output size lets you create exactly the grade you need for backfill or road base. Cutting long, clean trenches usually takes time, but the LIBA GM 140 turns it into a one-pass job that looks seriously fun to operate. Mounted on a tractor, this trench cutter slices through soil with a heavy-duty milling wheel, creating perfectly shaped trenches for cables, irrigation, drainage pipes, or fiber optic lines. The depth and width can be adjusted on the fly, the spoil is neatly discharged beside the cut, and the machine keeps moving without clogging, even in tough ground. A full basement in just 2 days sounds impossible, but Leier's KSI system makes it surprisingly real. These precast concrete modules arrive as factory-finished wall and slab sections, complete with reinforcement, insulation, and perfectly smooth surfaces. A crane lowers each piece into the excavation, the joints are sealed, and the structure is ready for backfilling almost immediately. No waiting for concrete to cure, no complicated formwork, and no wasted time on site. The result is a strong, waterproof cellar that's ready for installation of utilities almost as soon as it's set. But what do you think? Would you trust a fully precast basement over a traditional poured one? Let us know in the comments. If you think bridges need to be heavy and slow to build, this system will change your mind. Optem's composite bridges use ultra-light, high-strength panels that arrive ready to install. Crews lift each section into place and lock them together in hours, not weeks. The material doesn't rust, crack, or absorb moisture, which means almost no maintenance and a much longer lifespan. If you've ever wondered how long concrete bridges get built over valleys, rivers, or active highways without shutting everything down, this machine is the secret. The Strukturas underslung MSS system travels under the bridge deck, supporting all the formwork needed to cast each segment right where it hangs. Its steel truss can handle hundreds of tons, keeping the deck perfectly aligned as crews install rebar, place form panels, and pour concrete. Once a segment cures, the entire MSS unit slides forward to the next position, repeating the process with incredible accuracy. And that wraps up our look at these game-changing construction techniques and machines. Which one was your favorite? Drop it in the comments. I'd love to see what stood out to you.